Let's talk about governance and security in AI deployments. We're not necessarily talking about cybersecurity when we talk about security. We're talking about poisonous language, bias, the wrong data being ingested by an AI and spat out at the wrong point or in the wrong place or to the wrong person. It's these issues that are the ones that are at stake rather than masked men in their basement tapping away at keyboards.
Well, it's a bit of both.
Yeah.
Right. But I think, look, I mean, we've had cybersecurity concerns when I got into the business. It was called information security back in the day.
Yeah.
That's been around for a long time. A lot of the risk domains we've talked about, network security, et cetera, been around a long time. Those are not new. In the AI world, they're not new, right? So a lot of times what we're talking about is okay, you're not rebuilding your security program. You're enhancing your security program to address the gaps between where you are today and the implications of AI, right? And so to your point, as you think about, testing systems, we've done security testing systems for a long time.
For sure.
I started off in pen testing many years ago, right? But what we weren't doing is actually looking at the data. We weren't testing the data itself. We weren't looking for what's the source of the data. Can we rely upon that source? Test data is now a point of vulnerability, which historically it has never been, right? So there has to be tighter integration between data science and cybersecurity going forward, because yes, there are vulnerabilities that are being introduced by these technologies that historically we've not dealt with.
I'm intrigued. Test data is not necessarily a threat, but it might be a source of risk. Tell me a bit, why is test data?
Well, it's an example. So if you're building a model and you want a model to generate a certain outcome, right? And I have a desire to have your model generate a different outcome, right? Or maybe outcomes that are unique to something that I want to do. If I can modify the test data that's going to train the model, it's going to end up in the model behavior. So I'm manipulating the ultimate model behavior by altering the test data. Now you can do that intentionally, right? You can also just do it through accident.
Yeah.
If you're using test data, you don't know the source of the data. It's not, you're not careful about toxicity and bias and those kinds of things. You are likely to introduce an issue into your AI, right? Particularly when you start getting to, the agency side of AI, where you've got agents making decisions autonomously based on information, that can either be an accident or it could be an intent, but those are things that we historically have not really worried.
And is there a set rule book, a playbook that you guys recommend to people considering getting their AI models out of development into prod? Is there a kind of checklist, a simple checklist that people can go through, the processes that they can undertake to sort of give themselves the best chance of not putting a foot wrong when things do go live?
But there are frameworks you can use to think about how to secure it. And then you have to instrument those into your software development lifecycle and your model development lifecycle to incorporate those controls and those checks to make sure you actually have it instituted in the way you're building systems.
Yeah.
Right. So again, this is, everyone probably has an approach for secure software development, but you're going to have to add to it to make it effective in an AI situation.
And Kieran he wears many hats. And I mentioned earlier on that you come from the world of trad, cybersecurity. I want to switch now to cybersecurity, capital C, uppercase C. Okay. I've heard of several cybersecurity platforms that are powered by AI.
Yeah.
And it seems to be sort of anomaly detection at a network level. That seems to be the dark trace model. There's nothing really that I'm convinced by in terms of 0-day prediction, but there may well be. I would like to be surprised by that. If we're talking about AI being used in the SOC or somewhere in the cybersecurity stack, are we not just talking about another tool that raises red flags to overworked cybersecurity professionals.
I mean, you could create that scenario, right? If you go with a traditional approach. So if you're still thinking in a traditional SOC model, and you get more tooling and you generate more alerts, 100% you're going to be contributing to alert fatigue. You're not necessarily solving for the underlying issues. Now, some of the products are leveraging AI in ways to advance detection capabilities, but beyond that, also, contextualize and combine data in a more usable format for the SOC. So, for example, an alert, any given security incident could trigger alerts in 16 different security tools. Right. So if the analyst has to go find those things and then look at all the timestamps, manually figure out the course, that path, the path that took.
Oh,
that's
all
all
within 4 seconds.
So, correct. Within time. So you can use AI to do that quite effectively. And so what the analyst is looking at is a confirmed incident that's showing how all these events tie together. And you actually know then what the path was, what the target was. And now you're much better positioned to respond to it, right? As opposed to only seeing it at an app firewall, only seeing it at the network level. So there's those kind of advances, and those are important. Additionally, that you can use AI, just like in other parts of the business, to be more effective, be more efficient. So one example I would give is we built for ourselves, and we run managed SOCs for clients, digital analyst, right? It's an L1 triage analyst. It takes the inbound alert, it adds context, looks back at the ticket history for that client, their network, what has previously occurred. And based on that, it comes up with a recommendation to say, this has been seen before. Here's how it was fixed in the 42 other situations where it was seen. And here's the summary of how you need to fix this. Right? That greatly reduces the response time, takes it down by, 80%, right? That's a speed gain. That's a better outcome. If it is a significant event, you've shortened the time frame materially. Those are all important advantages to be gained. So there's definitely opportunity there. You just have to go today. You got to build some of it.
Yeah. So it's improvements to internal processes often rather than empowering cybersecurity professionals with a sense of second sight thanks to AI. It's more
I would argue you can get there too. Okay. So we've done a lot of work around lateral movement. It's funny you brought it up, and zero-day threat detection.
Right.
Now that is fairly complex, advanced data science work.
I was going to say, I couldn't even imagine where to begin.
Yeah. And I won't try to explain it to you because I won't do a great job. Right. I'll grab Chris.
He doesn't really understand.
Yeah. So we've done some work in that space, but honestly, most companies shouldn't go after that until they're doing the fundamentals really, really well. Okay. Right. And there's a lot of value to be had in doing the fundamentals well. And I think sometimes people get distracted by trying to do something super advanced. But again, if you're not doing the fundamentals really well, if you're not optimized, if you don't have good response times, if you can't automate response, right, then worrying about lateral movement and detecting lateral movement based on fake signals in a vast amount of data is probably not your number one issue, right? And we've got, I think, information on those models available and websites and so forth. People want to know more. We've written research papers around it, so it's pretty available.
Okay, let's draw things to a close. Last thing is, I guess, this idea of it all comes down to the data. This is the message I keep hearing. Everyone I talked about AI, it's about data governance, i.e. governing data as opposed to some kind of statutory governmental element. It's how you look after your data. It's how you pass it. It's how it's drawn together. And then it's examined for bias. And it is generally, I guess, not sanitized, but made safe. This appears to be the theme that keeps coming up and coming up again. And in fact, is it not, I wouldn't say a business problem as old as the hills, but this data treatment issue is old in business. It's always been the way we've talked about data silos. We've talked about data silos for years. And now all of a sudden, it's not even all of a sudden, just solving those more core issues has become a whole lot more important because of the capability of AI and also the capability of AI to go wrong.
Yeah. So there's a lot there. what I would say is if you ask the data scientists and ML crowd, oh, is this an issue? They're going to tell you that was an issue years ago. We've been dealing with this problem for a long time. It's fair answer. Your models are going to be, the effectiveness of your models will be limited by the quality and the volume and other aspects of your data. 100%. Are you, or should you rush to make all data in your enterprise available to AI? I would argue no. Right. The reason I would argue that is because, practically speaking, I know that in many organizations, underlying controls like RBAC and identity management and other things are not at a place where you can suddenly expose any element of data to AI or to the people in your enterprise and not encounter situations where people have access to data they shouldn't.
Yeah.
Right. So the way we think about it is, if you're going to build an AI platform, you probably want to think about data within that platform environment in a different way than you do for the rest of user land network of your corporate enterprise, right? And you do have to tag your data, like 100%. If you want to protect it all the way through the process, you have to tag it, you have to label it. There's other things you need to do. You can do that on a more constrained basis to start and then go after the broader enterprise data as you go forward. But I wouldn't start by trying to, swallow the entire off.
Yeah, I suppose I'm informed by the idea that the bigger the learning corpus, the better.
That's true in many instances, but in some cases it's not. In some, if you're thinking about models, and certainly if you're thinking about purpose-built models or smaller models as opposed to giant LLMs, the quality of the data and the accuracy of the data is super important. You may not need a large volume of data. What you may need is a small volume of highly accurate data.
Yeah. Which I guess is why data scientists, until recently at least, were very happy with a 500 gig drive on their laptop, and they just had the data set on that and they just worked from that, and that was fine. Thank you very much.
Yeah. I think in many cases, so you don't always need a big model, right? Sometimes, by using a smaller model, you're going to get better outcomes, meaning it'll be more accurate. You also reduce your risk profile by using a smaller model. And of course, from a cost and efficiency perspective, you're better off. So a lot has to go into the model lifecycle development process to think about those choices early on. And again, an integrated, thought process around what's effective and what's efficient from a data science perspective, but also what's beneficial from a student perspective.